So for example number 3, or I'm sorry, example number 2, let's zoom in and read this thing and see what the textbook is trying to teach us. Again, like I said, it's almost as if they've written this book to teach us math. Almost. Alright, let's look at this bad boy. Here it is. It says table 1-2 shows us the growth in number of prisoners incarcerated in state and federal prisons from 1980 to 2000. Is the proportion of female prisoners over the years increasing? So that's what we're going to look at. So let's look at that table and get an idea of what we're talking about. So this is the table here. Let me zoom in on it a little bit and see what we've got here. We've got male to female, and we're only going to focus on table 1-2. So let me zoom really close in on that so you guys can see that. We'll take a snapshot of that. All right. So now, if I look at this, the question that they asked us was, is the proportion of female prisoners over the years increasing? So now, in order to do that, what I would need to do is we're going to come in and basically we're going to look at the proportion of male to female here, right? And then compare it to here. So we're going to have to do that quantitatively, and what that means is we look at it and we can see that there's an increase in the male population. It almost quadruples, right? 300 to 1200. But there's also an increase in the female population, 12 to 92. Well, does the female population quadruple, or does it increase more than quadruple? It's more. So, I mean, we could do the math to quantitatively justify it, but qualitatively, just by looking at it, we could see that there is an increase in the female population. So there's lots of ways that you could do that. You could compare it to the total. In other words, what percentage of the total would be one approach. You could compare the male to female ratio. And I think we'll do that. The textbook doesn't really do one or the other, but I think I will do that. So what I'm going to do is I'm going to come in here and let's compare the two, okay? Let me get rid of my highlight there. And let's compare the two. So if I, based on that table, let's just do male to female, all right? That's a good thing to do because that's really what we're measuring. So I'm going to come in here, and so in 1980, there were 304 males to 12 females. And I'm just going to skip ahead because the question is asking from 1980 to 2000. There were 1,290 to 92. So if we were to reduce this, we could write this as 304 to 12, and then enter that in a calculator and then determine what that value is. So if I come in here, open up my calculator, which I can't see because I have too many things on my screen. All right, there it is. So I'm just going to enter in to my calculator 304 divided by 12, and that'll give me an approximation. So now what this says is that there is really 25.3 males to 1 female. That's what that's saying. 25.3 repeating males to 1 female. Okay? Now we're going to enter in the other number, which would be 1290 over 92. So if I enter in 1290, so I'm going to hit 1290 divided by 92. That seems weird. 14.02. Now what's throwing us off about this? And Mr. Adams did this on purpose. What do you notice about our numbers? See, we had 25 males to 1 female in 1980, but in the year 2000, the number of males to female went down 14 to 1. What's the question asking? Is the female ratio increasing? Do the numbers match up? Think about what the numbers represent though. The male to female ratio is decreasing. So the females are increasing. Does that make sense? So now this is a common misconception and we have to really think things through. You might, when you do your homework, accidentally do things backwards, right? So I didn't do this backwards. The numbers don't lie. They're accurate. My male to female population decreased. That's what the numbers I have written down, and the way I selected them, the way I chose to represent the data, showed a decrease in male to female. But the question was, did the female to male population increase? So my question to you is, how could I rewrite these ratios to show that the female population increased? Could I say 12 to 304? Just like our unit conversions in physics, the ratio is an equivalent statement, right? So I could write it this way. So what we're really showing here is female. My first number will be female to male. So now if I enter this in the calculator and I say almost goofed up again. 12 divided by 304, I get 0.0394 females to every 1 male. Does that make sense? So it's roughly about 4% of the population is female. Now, that's 1980. If I do the year 2000, I'm going to have 92 females to every 1,290 males. And if I reduce that, in other words, if I come in here and I say 92 divided by 1,290, I get 0.0713 to every 1 male. So when I write the numbers this way, is it clear? Does it show that there's an increase in female population? Yes. So what if when you do your homework you accidentally do it the same way Mr. Adams did the first time? What's the key to making sure you have the right answer on the ACT? By the way, the ACT would have both numbers, right? They would say, no, there isn't an increase, and then show these exact same numbers. And then option B would say, yes, there is an increase, and then show these exact same numbers. Well, if you did this way and saw the same numbers, you would select, no, there isn't an increase, unless you thought about it, right? So the key here is to thinking, using those things inside your skulls, more commonly referred to as brains. Yes, Mr. Adams, we'll use our brains.